So, tonight what we're going to be working on are solving equations that have exponentials and logs. And so the big thing we talked about the other day is that exponentials and logs are opposites of one another. And just like with squares and square roots and cube roots, we use inverse functions to help us solve equations. The first night that we introduced logs, we practiced a whole section of rewriting exponentials as a log and rewriting a log as an exponential. And the reason we do this is that's how we solve exponential and log equations, is by rewriting it as the other function, and that way we can solve. So as far as steps for solving these equations, our first step is still going to be to isolate the function. That's kind of been the theme for the past couple of units. We have to actually get the exponential by itself or get the log by itself, and then once we have the log by itself or the exponential by itself, then we are going to rewrite as the opposite function. So if it's a log, then I'm going to rewrite it as an exponential. If it's an exponential, I'm going to rewrite it as a log. So we're going to rewrite it as the opposite function. What this does is it rearranges where the x is, and so now the x, instead of being up in the exponent, it's going to be down at the bottom, and the rest of it's something that we can type in our calculator and simplify. Or instead of x being inside the log is going to be gone, and again, we'll have stuff that we can type in our calculator and we can simplify. So we're going to isolate, we're going to rewrite the opposite function, rewrite as the opposite function, and then our third step is to finish solving. Whatever we're left with, again, sometimes it's a linear equation, sometimes that's a quadratic equation. We have to kind of play that by ear, and we're going to finish solving. So these are our steps to follow. So let's look at some example problems. You'll definitely want to have your calculator handy. These are going to be problems that we are going to be rounding the answers, so please pay close attention to directions. Always round to whatever the directions tell you to round to. If the directions don't tell you, our default is 2 decimal places, or the hundredths. So make sure that you're rounding appropriately. So let's say I have 3 times 1/3 to the x plus 2 minus 5 is equal to 10. Alright, so I want to solve this exponential equation. So I need to follow my steps. My first step is to isolate. So I need to get the exponential by itself. Please remember the exponential is where x is in the exponent. So that's just the base and the exponent. What I'm trying to isolate is this part. So that means anything that's not the base and the exponent, I need to get rid of. So that means that I need to add 5 to both sides, and that will get rid of that. I still have 3 times 1/3 to the x plus 2, and now it's equal to 15. But this is still the exponential. I still need to get rid of the 3. Please be aware, I cannot, under any circumstances, multiply these two times each other. Order of operations says exponents must be done before multiplication, and since we don't know what x is, we can't do the exponent. I cannot multiply by 3. So I do have to divide those out, and I'm going to get 1/3 to the x plus 2 power is equal to 5. So this was my first step, to isolate. I had to get the exponential by itself. Step number 2 is to rewrite as the opposite function. Well, this is an exponential, so I want to rewrite it as a log. So if you remember, a base is a base is a base. So the base of the exponential was 1/3. That means this is going to be a log base 1/3. It's always equal to the exponent. Logs are equal to an exponent. So my exponent was x plus 2. That's going to go over here. And then the number that it was equal to is what goes inside of the log. So again, I'm going to double check. 1/3 to the x plus 2 power is equal to 5. I rewrote it as a log. This, even though it has a fraction and it's a log, is still something I can type into my calculator and get a decimal. So now I'm going to go into my calculator. I have an old calculator, so I am going to have to use the change of base formula. Don't forget our change of base formula. If you have one of the nicer new ones and it lets you actually put the base in, don't forget you do need the whole fraction 1/3. Don't just put 0.33. That's going to be rounding it, so make sure you use the fraction 1/3. So I'm going to type into my calculator log 5 divided by log of 1/3, and that's going to give me whatever log base 1/3 of 5 is, and that gives me negative 1.46 blah 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 blah. Please notice, and this is important, folks, I'm keeping the blah 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 part. You cannot round in these problems. In fact, make a note. Can't round till the end. You do not want to round until you get to the very end. If you round in a step previous to the very end, because we're dealing with exponents and things like that, one decimal place can actually change your answer drastically. Because when you think about it, one decimal place is a whole percentage point. Sometimes it could be 10 percentage points. So you want to make sure that that you're not rounding until you get to the very, very end. So what I do, for the sake of, again, not having to write too much, is I'm going to keep all of those in my calculator. I'm just going to put dot, 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 dot here. I'll round when I get to the very end, because now I'm to my third step, which is to finish solving. And the only thing I have left with x is my plus 2. So I do need to subtract 2 from both sides. So I'm going to subtract 2 from both sides, and I'm going to get that x is equal to, and again on your calculator, to keep all the decimal places, don't forget answer above the negative sign. You can do the previous answer minus 2, and it holds all those decimal places for you. Now that I'm at this last step, I can approximate. X is approximately, because we are dealing with decimals at this point, negative 3.46. Now it doesn't round up because that number next to it was a 4, so it's going to stay 0.46. So negative 3.46 is my solution for this particular exponential problem. So step 1, isolate the exponential or log. Step 2, rewrite it as the opposite function. And then step 3, finish solving whatever it was you were doing, but don't round until the very, very, very last step when you're writing what x is equal to. Another example of these 3 steps with a log problem. Let's look at a log problem. If I have natural log of 2x plus 5 is equal to 12, all right, my first step, again, is going to be to isolate. And in this case, it actually is. 2x plus 5 is inside the log, so I can't actually do anything with that. There's nothing going on outside of the log. I've got nothing being multiplied. I've got nothing being added or subtracted, so this is as isolated as it's going to get. So now I can check that step off and move on to step number 2, which was to rewrite as an exponential. Now, with ln, we do need to actually remember that I've got a base, even though it's not written here. ln is the natural log. It's log base e. So you may want to rewrite it just for your own sake as log base e of 2x plus 5 is equal to 12. That may make it easier for you to rewrite it as an exponential. Don't forget that when we rewrite a log as an exponential, it's the base to this power is equal to this. It's always equal to the exponent. So that means that this, when I rewrite it as an exponential, is going to be e to the 12th power is equal to 2x plus 5. Again, e to the 12th power, although a decimal, I can at least find it, and then I can finish solving. So step number 3 is to finish solving. And so to do that, I am going to have to subtract 5 from both sides. So I have e to the 12th minus 5 is equal to 2x. Then I'm going to divide everything by 2, and I get, and this is where my calculator is going to come into play here. Pull up my calculator here. So I need to figure out what is e to the 12th power. So e to the 12th power, and it's going to give me the decimal for that. I am subtracting 5 from it, and then I am dividing it by 2, and it looks like I got 81,374. And then let's look, 89, but that is bigger, so that's going to round up to 0.90. So x is equal to 81,374.90.